I can't stress this often enough that you should always use consts for array sizes and make them as descriptive as possible. These are good examples. So this is setting up an array of size 5 but not putting the 5 as a magic number right into the array declaration. Instead, you set up a const int and even a descriptive name, number of students equals 5, and then you set up the array. This is much better, improves readability. It makes it more versatile. What does that mean? It means that if you have an array and a loop and you use the number itself in the array declaration, then you have to use the number in the loop as well. And if you change one of them, well, the other one's broken. But if you use consts like this, if you use consts, then you change it in one place and everything is changed. If you have 100 loops, they're all, if you use this const in all of the loops, they're all changed. That's what we mean by improving versatility, and it's also more maintainable. Okay, so use this defined constant everywhere that the size of the array is needed. So for example, in a for loop, you want to use the size of the array rather than the number 5. If you use 5 here and you change the size of the array, now you got to fix all your for loops. That's a pain. Okay, so if the size changes, you only need one change in the program. If you have 100 loops, no problem. Okay, so arrays are just chunks of memory. Remember, and we will run to this problem again, in Java, arrays always had a public final int, which was the size of the array, and it was called length. So every array had a dot length. There's nothing like that in C++. Try to use it, you'll just get an error message. So there is no array name dot length or a dot length in C++. In Java, it was great. Every single array knew how big it was. C++, array is just a chunk of memory, and actually the array itself doesn't know how big it is. Okay, so these are simple variables. There's memory allocated in an address. Array declarations allocate memory for the entire array, and it's sequentially allocated just like in Java. This means that addresses allocated are back to back, they're right next to each other. And in Java, arrays are the way we access array elements are a lot more controlled. In C++, we can do a lot of low-level C stuff that uses the fact that these memory locations are right next to each other. In Java, we actually never use that piece of information, that the actual locations of the various elements are actually right next to each other in memory. C++, we can use that fact to make things more efficient. So if we were able to look into memory, and let's say each of these is actually this doesn't really, it looks like in this example and from the book, each memory location is 2 bytes, I guess. Alright, so we can go with that. So each memory location is 2 bytes, and so a sub 0 is, since a is an int, takes up 4 bytes, that is 2 of these locations. 2 bytes here, 2 bytes here. And then the next array location a sub 1 is right next to it. There's no gap or anything like that. And it turns out we can use this information in the way we do some what's called pointer arithmetic. And we'll get into the details later. And we can use the fact that these locations are right next to each other. In Java, we never use that information. We just use straight information about the indices themselves. We never really try to figure out how we can access nearby locations. We always just do a sub 4, things like that. Okay. So there is this very nice display in the book. I would encourage you to look at it. If you're not sure how arrays work, definitely look at this. So just like you can initialize simple variables while just where you declare it, so you're declaring price to be an int, and you can initialize it right here. You can also do the same thing with arrays. We've done this in Java. You can use the open curly brace notation. So you can say right here, this would not be in Java. You cannot do this in Java, but you can do this part, equals this thing. Okay, so we can say int children, it has 3 elements, equals, and then initialize all 3 elements right there. This is equivalent to saying we have an int array of 3 children, and children sub 0 is this thing, children sub 1 is the second thing, and so on. And there are some more complicated things that you can do. You can actually just initialize one location. You don't have to initialize all of them. And also, you can auto-initialize arrays and not really say what the size is. You can do this notation. You can say int b, this is the name of the array, open close square brackets, equals however many elements you need. And C++ will automatically decide, based on the number of elements that you have, that it'll say, okay, b is exactly size 3. It has only 3 elements. So it's a little different. If you set the size of the array to 3, you can initialize the first one, or the first and second one, or the first 3. Any one of those would be accepted. If you supply fewer values than the size, so if you have an actual array of size 3 and you only supply one element in curly braces, then it always fills from the beginning and fills the rest with 0 of the array base type. So whatever, if you have an int array and you only initialize the first one, the rest will be set to 0. We can have arrays and functions as arguments. Like I mentioned, we can also return arrays from a function, but we're going to need some additional information that we discussed in chapter 10 to really be able to do this. So this is not really discussed here. In Java, we can return values. You can return an array as a value from a method, and the way to do that is to use the new operator inside the method and return an array like that. And we'll do the same thing in C++. So it's just that we don't talk about the new operator until much later. Okay, so why would you want to pass in an array as an argument? Well, you're passing in a whole bunch of things as one thing. Instead of, the alternative would be to have, if you have an array of 10 things, you have 10 parameters. No, that's just too much work. So it's very convenient to be able to pass an entire array as a single entity into a function. And once there's no, most of you have used this, right? You've passed in parameters as an array, and it works the same way in Java and C++. So an indexed variable can be handled the same way as any other regular variable. So you can, let's say you have functions, a void function which takes a single, double. You can pass in a sub 3. That's perfectly fine. You can pass in an int if you want to. That's promoted to a double. That's fine. You can pass in an n to. We can pass in a double as well. Okay, so all of these are fine. So if A is an array of doubles, this will work. If A is an array of ints, A sub 3 will also work, just because promotion kicks in. Alright, so when you do indexing, one thing that you want to maybe think about, it won't be that crucial right now, is that what the C++ compiler does is it'll determine what value I has first, and then it will determine, well, what is a sub I, and is it the right type to pass in? Well, it'll pass it in. So the compiler will just check the type. Is A compatible Is the individual elements of A compatible with what this function requires as an argument, as a parameter? And if it is, then when at runtime, it'll compute the value of I first. That's determined. And then it'll determine where this element is, and then it'll pass that in. So you can do something, you can do any kind of expression is what it comes down to. As long as, well, actually the compiler doesn't warn you if this is out of bounds. You are responsible. You, the programmer, is responsible for staying in the bounds of the array. Okay, so you've passed in arrays as arguments to a function. In Java, you can do the same thing in C++. There's some tiny differences, and we'll talk about that well, actually, let's take a look at that. So what I've done is I've set up a simple program. Oh, here it is. Here is a simple function that takes an array of ints. And one thing that's different in C++ from Java is that whenever you pass an array, you have to pass in the size of the array. Otherwise, the array could be declared in one place. And then remember that in C++, this array does not have an a.length. Okay, so this array only occupies just enough memory for size number of ints. So if size is 3, it just has enough memory locations or memory for 3 ints, which is 12 bytes exactly. No more than that. So in Java, things are different. If you have an array of size 3, you have those 3 ints, and plus, in addition, you have a length data member that's set to 3. No such thing in C++, and so as a result, you have to tell other functions exactly how big this array is. Now, is this checked by the compiler? No. This is something that the programmer has to do. I just so happen to have this sum function in a separate file, and you can do that. So I have this, in this case, I have the sum function in a separate file, and that's it just means you have 2 files now. Array, in this case, arrays1.cpp and sum.cpp. I put it in a separate file. That's just to show you that you cannot assume that that size information is available inside this function. It could be anywhere. This function could be somewhere in some other, maybe in some other folder and some stuff like that. You have no way of figuring out inside this function how big A is unless the size is passed in. And if that's passed in, then you can set up your loops like this: for int I equals 0, I less than size, I plus plus, just like any other. It's like sort of like using it in Java, except that instead of a.length, you have to have this information passed in as a function parameter. So that's one other big difference, another big difference between arrays in C++ versus Java. So you can send the entire array in one shot, and the argument is then passed in. The function call is the array name, and this is called an array parameter. And the thing you always have to do, if you're sending an array, you send the size of the array as well. And the compiler doesn't check on this, and so definitely this is something that you, the programmer, is responsible